Okay, so today we are diving into press production optimization. Well, we've got some really interesting articles and studies here. And I have to say, I'm already fascinated by these industrial giants, I guess you could call them, these press machines. You don't really think about them much in everyday life, but they're behind so many of the things that we use.
Yeah, absolutely. They're kind of the unsung heroes of manufacturing. They're shaping and molding everything from, car parts to our smartphones.
Exactly. So before we even get into how we can make these machines more efficient, maybe we could take a step back. Could you give us a jargon-free explanation of what a press machine even is?
Sure, imagine like you have this incredibly strong hand, right?
Mm-hmm.
And it can apply a ton of pressure to mold or cut or even fuse materials together. So essentially that's what a press machine does. You take a raw material like say a sheet of metal or even like a wood composite, and using a die, which is kind of like I guess you'd call it a supersized cookie cutter, it presses that material into a desired shape.
Okay, yeah, that makes sense. So we're not just talking about like massive industrial applications here. I'm seeing in our sources, they mention cars, electronics, furniture, even parts of buildings being shaped by these presses. Pretty mind-blowing how much we rely on them.
It really is. And, if we take a step back and look historically, the idea of pressing,
Yeah.
it's been around forever. I mean, you think about like the earliest humans using stones to extract juice or shape tools, right?
Right.
But as with a lot of things, the Industrial Revolution came along and really supercharged this technology. It took us from these simple hand-operated presses to these massive machines that we see today. I mean, they can exert enough force to crush a car, like a soda can.
Wow.
Yeah.
And speaking of different types of presses, I'm seeing in the sources we have mechanical, hydraulic, pneumatic. It seems like choosing the right press is almost like, picking the right tool out of a toolbox.
It is. Each one has its own strengths and weaknesses.
Right.
So, like mechanical presses, they're kind of the workhorses, for those fast, repetitive tasks. Like, think of stamping out metal parts on an assembly line. They use a huge flywheel to store energy, and then they release it really quickly with incredible power.
That makes sense. So if you need like a more delicate touch, more control, that's where the hydraulics would come in.
Exactly. Hydraulic presses, they use fluid pressure to generate that force. So that gives them, that huge amount of power, but also the ability to hold that pressure for a long time, which is really important for things like deep drawing. You're basically shaping those more complex shapes.
So for example, like the curves of a car door would probably require a hydraulic press.
Exactly. You got it. Now, on the other hand, we have pneumatic presses, which use compressed air. They're not going to have the raw power of a hydraulic press, but they're faster, they're cleaner, and they're perfect for those lighter applications like assembling electronics or packaging.
So you choose your press based on like the material and the specific task at hand. It's, like you said, the right tool for the job. But this is where I think it gets really interesting. We have this study here from Pamukkale Universitesi Mühendislik Bilimleri Dergisi, and they were really focused on this idea of optimizing press time for particle board production. And they managed to shave off over 2 seconds, which, 2 seconds might not sound like a lot, but...
But, in the manufacturing world, time is money, right? So 2 seconds per cycle, that's huge. Think about it. A factory producing thousands, if not millions, of units. Those seconds really add up. That's cost savings, it's increased production capacity, it's a competitive advantage.
Okay, so the stakes are high when it comes to optimizing these processes. And what I thought was so interesting in the study was how they actually achieved those time savings. It wasn't just about making the press go faster. They were really analyzing things like temperature curves during the pressing, the resin content of the particle board, even the pressure applied at different stages.
Yeah, it's like fine-tuning a recipe. You're not just going to throw all the ingredients together at any temperature and hope it comes out right. There's a science to it. You need that precise combination of factors to get that optimal outcome.
Yeah.
And in this case, even those tiny adjustments, they led to those crucial seconds being saved.
Yeah. It really highlights how much complexity there is behind something that we might just totally take for granted. You think about a piece of furniture or something.
Absolutely. And speaking of those hidden complexities, that actually brings us to another level of innovation. Counterbalance cylinders. I was reading about this in the Muhendis v. Machina source.
Yes, they had some really impressive results, those counterbalance cylinders, in terms of efficiency gains. But before we get into that, can you give us like a crash course on what they are and how they work? I'm picturing something like a seesaw in my mind.
You're not far off. Okay, so imagine like a swing set, right? You swing back, you're storing that potential energy, and then when you swing forward, that energy is released. So counterbalance cylinders, they work in a similar way. They're helping to offset the weight of the press itself during that return stroke, like almost like having a counterweight on that swing.
Okay. And the return stroke being when, like, the press resets for the next cycle, I'm already getting the feeling that that seemingly simple motion is more important than I realized.
It is, and interesting because in some hydraulic presses, that return stroke, it can actually use more energy than the actual pressing action itself.
Okay, that's wild.
It's true. And it's a perfect example of why these deep dives are so fascinating. We uncover these inefficiencies in the most unexpected places.
So we're talking about optimizing a process I wouldn't have even thought twice about. And the results, like you said, really incredible. That Muhendes ve Makina study they found.
A 19% increase in production.
Wow.
And a 23% reduction in energy consumption, just by adding these counterbalance cylinders.
Those are some serious gains. So why aren't these things standard on every hydraulic press? I mean, there's got to be a catch, right?
Yeah. There's always a trade-off. So while they're really effective counterbalance cylinders, they do add complexity to the design, and they can be more expensive up front. It's not as easy as just, bolting on a weight. These systems, they need to be like really carefully engineered for that specific press. You have to take into account the materials, how fast you want the cycle to run, and all while making sure that they don't interfere with that. With the actual pressing force itself. It's a real challenge for the engineers designing them.
Yeah, that makes sense. A more complex system probably requires more, specialized knowledge to design it, to install it, to maintain it. I imagine for some manufacturers, especially those with older equipment or maybe smaller production runs, that upfront cost might be a bit harder to swallow, even if there are those long-term benefits.
Exactly. But, as technology gets better, those costs will likely come down, and we could see them being used more widely. And that actually makes me think of another study that we have. This one's from the Konya Journal of Engineering Sciences. They were talking about how technology like servo motors is really changing how we think about hydraulic presses.
Okay, so instead of just making the mechanics better, we're now talking about adding in, more sophisticated control systems.
Yeah, exactly. So think about it this way. A lot of these older hydraulic presses, they use, fixed speed pumps and valves, which means they're using up a lot of energy, even when they don't need to. But a servo motor-driven press, that gives you incredibly precise control over the pressure, the flow rate. It's almost like having like a dimmer switch for your hydraulic power. You only use what you need when you need it.
So less wasted energy, which means lower costs, better for the environment as well. But what about the product itself? I mean, does this level of control, does that actually translate into a higher quality product?
Yeah, absolutely it can. But, by really controlling that pressing process so precisely, you can get much tighter tolerances, you can reduce inconsistencies. And what that means is you get a higher quality part with less waste.
And of course, less waste means less material being used, which again, lowers costs and it's better for the environment. Seems like a win-win situation all around. But I'm guessing this level of sophistication, it probably comes with its own set of challenges.
Yeah, you're right. One of the main challenges with these servo-driven systems is that they are more complex. So it takes more specialized knowledge to use them and to maintain them.
Yeah.
So it's not just about the manufacturers buying the technology. They have to invest in training their workforce, making sure that they can use this advanced technology. It's kind of shifting the whole manufacturing landscape.
Right. We're really moving toward a more tech-savvy workforce. And speaking of tech-savvy, this Konya study, they also mentioned something called fuzzy logic control, which, I have to say, sounds a little intimidating. Can you maybe break that down for us? What is fuzzy logic, and why is it relevant to press production?
Yeah, no, it sounds like something out of like a science fiction movie. But it's a really cool approach to control systems. So think about it like this. Traditional control systems, they're very black and white. They're either on or off.
Right.
But fuzzy logic, that embraces the gray area. It allows the system to deal with, uncertainty and make decisions based on a lot of different inputs, kind of like how we do as humans.
Okay, so less like a robot, more like an experienced operator who can kind of feel out the process and adjust as needed.
Yeah, exactly. So instead of just, applying full pressure or no pressure at all, a fuzzy logic system can adjust that pressure and the flow rate in a much more, I guess, nuanced way, right? It takes into account like the material thickness or if there are any changes in temperature, even how much wear and tear there is on the press.
Wow. So we're basically taking like human expertise and embedding it into the control system, which allows the press to like adapt and optimize itself as it runs.
Exactly. And that's really what Industry 4.0 is all about. Kind of that line between human intelligence and machine intelligence starting to blur. But before we go too far into the future, there was something I wanted to touch on. I was thinking about this study, the Duce Universității Bilimve Tehnologii Drăghiții study.
Okay, what did we miss?
They were really focused on the structure of the press frame itself. It's a good reminder that even with all this new technology and automation, you still need solid mechanical engineering as the base for a good press, you know.
So you could have the most advanced control system in the world, but if the press frame itself fails, then it's all for nothing.
Exactly. And this Ducey study, they use this thing called finite element analysis, which sounds really complicated. But essentially what it lets engineers do is it lets them test out the press frame virtually. You know? So before they even build it, they can see how it holds up under different stresses and strains. And that means they can optimize things like the thickness of the steel plates. So they make sure the frame is strong enough, but that it's also as light as possible.
And I'm guessing that like reducing the weight of something as big as a press frame, that must have like a ripple effect through the whole system.
It does. Lighter frame means less material, which means lower manufacturing costs. And it could even mean that you need less energy to run it because the press isn't working as hard to move itself.
Right. So we've gone from saving like fractions of a second in press time to thinking about redesigning the whole structure of the press. And it's all in the name of efficiency. It really just shows how everything in the manufacturing process, it's all connected.
It really is. And that interconnectedness is just going to become even more important as we get further into this whole Industry 4.0 thing.
And speaking of Industry 4.0, one of our sources here, I think this was also the Konya study, they were talking about these ideas of interconnectedness, data exchange, how those are already being applied in some really interesting ways.
Yeah, that's right. That study actually compared like those more traditional hydraulic presses with the ones that are driven by servo motors. And it's amazing how much more control and efficiency these newer systems can offer.
Yeah. And like we were saying before, it's not just about speed, it's about that precise control over the pressure and flow rate, which leads to
higher quality products, less waste, lower energy consumption. It all ties back to that precision. Every drop of hydraulic fluid, it represents energy, right? And these new systems are just so smart about how they use it. It's like, I don't know, think about watering your garden. You could use a fire hose, or you could use one of those drip irrigation systems that puts the water exactly where it needs to be.
And I imagine when you're talking about the kinds of tolerances and specifications that they're dealing with in manufacturing today, that level of precision is crucial.
Absolutely. But like we were saying before, this new technology, it's not without its challenges. That same Konya study, they brought up the complexity of these servo-driven systems. They need a different kind of skill set to run them, to keep them maintained. It's not just about buying the technology. Manufacturers have to invest in their people, make sure they can handle it all.
It really is a whole new world in manufacturing, isn't it? Moving away from the old mechanical systems and into these systems driven by software, electronics. It really makes you appreciate the human element even more, you know?
It does.
And speaking of the human element, that study also got into this idea of fuzzy logic control and how it's being used with these advanced presses. I gotta say, the more I learn about fuzzy logic, the more fascinated I am. It seems like such a different way of thinking about control systems.
It really is. It's like instead of being limited by just on or off, this black and white thinking, it embraces that gray area in between.
Right.
Like imagine baking a cake, right?
Yeah.
And your oven, it only has two settings. Full blast or off completely.
Right.
You're either going to get a burnt mess or something totally raw in the middle.
Yeah.
Fuzzy logic, it's like having an oven that understands those subtle differences in temperature and adjusts as it goes so you get that perfectly baked cake every time.
So instead of just blindly following a program, a fuzzy logic system can actually adapt to what's happening in the pressing process. It's making decisions based on real-time information, just like a person would.
Exactly. It considers everything, you know. How thick is the material? Is there any temperature variation? How much wear and tear is on the machine itself? Then it takes all that and adjusts the pressure, the flow rate, to make sure you get a consistent, high-quality result every time.
So it's almost like taking years and years of experience, like what a human operator would have, and putting it directly into the machine's control system.
That's a good way to put it.
It makes you wonder, like, where's the limit with this kind of technology? What else could we be doing with it?
That's what has everybody excited, I think. The engineers, the researchers, they see the potential here. And it really gets back to that bigger picture that we keep coming back to. the power of Industry 4.0.
Hmm.
It's not about making things bigger or faster just for the sake of it. It's about building these smart systems that can learn, that can adapt, that can optimize themselves. It's really changing what's possible in manufacturing.
And this goes beyond just making more money, right? I mean, we're talking about less waste, using less energy, creating a system that's better for the environment.
Absolutely.
Yeah.
And it's amazing to see the different avenues people are exploring. I mean, we've gone from these tiny adjustments to press time to rethinking the entire structure of the machine itself, all in the name of efficiency. And it just shows you there's no one single solution. It's about looking at the whole picture. Yeah.
It's like that old saying, for want of a nail, the shoe was lost. For want of a shoe, the horse was lost. It really makes you realize that even the smallest detail can have huge consequences.
That's a good analogy. And it highlights how important that curiosity is, always asking what if, or is there a better way to do this? That's what drives innovation. That's how we find those breakthroughs.
And that's what we've been doing today, isn't it? In this deep dive, we've gone from the basics of how a press works all the way to this incredible potential of Industry 4.0. Optimizing press time, using counterbalance cylinders, even redesigning the entire frame.
Yeah.
It all adds up.
It really does. We've seen how these systems work, the mechanics, but also the human ingenuity that goes into designing them, improving them. It's pretty remarkable.
It is. So the next time you see a product, anything really, that was made with a press, take a minute to think about everything that went into it, the innovation, the drive for efficiency, all of it. It's a testament to human ingenuity. It gives me hope for the future.
I agree.
And on that note, I think we'll wrap up our deep dive for today. Thanks to everyone for listening as we explore the world of press production optimization. And until next time, keep those gears turning, keep asking questions, and we'll see you on the next deep dive.